Okay, number 11. A space explorer finds himself some distance from the space vehicle, with no motion between himself and the vehicle. He throws a hammer of mass 2 kilograms away from himself in the direction opposite to that of the space vehicle at a speed of 15 meters per second. His mass is 100 kilograms. What is his resulting velocity? All right, so here he is, and he's holding a hammer. Okay? And he's going to throw this hammer this way. And it says the velocity of the hammer when he lets it go is 15 meters per second. And the mass of the hammer, it tells us, was 2 kilograms. His mass, person, is 100 kilograms. And it wants to know what's his velocity going to be. Well, clearly it's going to be in the opposite direction. And this is like an explosion again. These are the final velocities. The initial velocities are both 0. So when you go to the momentum, m of the person, v of the person initial, plus m of the hammer, v of the hammer initial, is equal to m of the person, v of the person final, m of the hammer, v of the hammer final. These two both go to 0. So bring the person over, negative m of the person, v of the person final, equals m of the hammer, v of the hammer final. And you're solving for the velocity of the person final. So divide, the negative comes to the other side, m of the hammer, v of the hammer final, divided by m of the person. So negative 2 kilograms times 15 meters per second divided by 100 kilograms. That's a negative there, just not a sig 2. Okay, on the top, negative 30 divided by 100. Mass of the, or velocity of the person is going to be negative 0.3. 30 divided by 100. Yeah, negative 0.3 meters per second, where the negative means opposite the hammer. So the hammer's going to go one way, and the space dude's going to go the other way. Okay, that was number 11. Number 12 has 2 parts to it. The first part says, a stationary bowling ball of unknown mass is hit on by another hard ball of mass 2.5 meters per second moving to the right. So we have, what was the mass of the hard ball? 2.5 kilograms. I think I said meters per second. Moving to the right, so v of 1, I'm going to call this guy 1, initial is equal to 5 meters per second to the right. And it hits our bowling ball, m2. We don't know its mass, but we know v2 initial is 0. And then it says the 2.5 kilogram ball rebounds with a velocity of 1 meter per second. So v1 final is equal to 1 meter per second, and that's going to be left. And it says the bowling ball moves to the right at 4 meters per second. So v2 final is 4 meters per second, and that's to the right. Okay, so it wants a couple of things. The first thing it wants to know is the mass. So we're going to do m1 v1 initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. Initially, the second guy isn't moving. We're looking for m2, so take your m1 v1 final to the other side, where it'll become negative, and then divide by v2 final. Okay, so this cancels out, and now we can fill our numbers in. So m2 is equal to m1, 2.5 kilograms, v1 initial, 5 meters per second. And then minus m1, 2.5 meters per kilograms, times, and rebounding, so it's 1 meter per second, but it needs to go in as a negative. and then you're going to divide that by V2 final, which is 4 meters per second to the right, so it goes in as a positive. So 12.5 minus 2.5, so 10 over 4. So are they both 2.5 kilograms, or did I screw that up? It's just making me worry now. Oh, it's added. I did screw that. 15 divided by 4. Didn't think they should work out to be the same. 15 divided by 4, so 3.75. I still may have screwed that up. Now I'm going to have to do it in the calculator. 2.5 times 5, and that's going to be plus 2.5. I didn't screw that up. Divided by 4, 3.75. I wasn't wrong, but I think on my sheet I have it wrong. 3.5 kilograms. Okay, and now it wants to know, is it elastic? And I'm not going to have enough room there. So now you need to go to the kinetic energy equation. So 1/2 m1v1 initial squared plus 1/2 m2v2 initial squared is equal to 1/2 m1v1 final squared plus 1/2 m2v2 final squared. This goes to 0. So initially this guy was, now that my sheet's turned over, 2.5 kilograms. And going to the right, and it was it 4 or 5? I think it was 4. No, I don't know. Oh, I could look at the other sheet, couldn't I? 5 meters per second squared equals 1/2 2.5 kilograms. Final was -1 meters per second squared plus 1/2, and we found this guy to be 3.75 kilograms, and his final was 4 meters per second squared. All right, so 25 and times 1.25 is 31.25, and it's going to be joules. So this is 1.25 joules plus 16, 8 times 3.75 is 30 joules. Oh, look at that. And when you add them together, you get 3.25 equals 3.25 joules. It is elastic. And so you write down here, elastic. They will not all be, I promise. Number 13. 2 swimmers simultaneously dive off opposite ends of a 50-kilogram canoe. So here's my canoe. It's 50 kgs. And we have one person on this side going this way, and we have one person on this side going this way. Okay? Person A, so we'll call this guy person A. Mass of 80 kilograms, so 80 kgs. Dives off the front end with a velocity, so V of A is 3 meters per second, and that's going to the front. Mass of B, B's back here, is 70 kilograms, and VB is 4 meters per second, and he's going off the back. Okay, so this time, and these are finals again, right? Initially, they're all there. They're all stationary, and now they're going to dive off. So we're going to have, and they're all together really in the beginning. MA plus MB plus MC are really all together this is the initial velocity. And then it becomes MAVA final plus MBVB final plus MCVC final. Now it doesn't matter. You could write these as separate terms. It absolutely doesn't matter because they're all 0. And you're looking for VC final, so you're going to take your other terms to the other side. Negative MAVA final minus MBVB